All right, today we're looking at Chapter 3, Lesson 3, which is talking about properties of addition and multiplication. So today we're focusing on some vocabulary, which are properties. Our math book should be open to page 128, and we're going to start off with our learning target. So today it's going to say, I can use properties to show that two expressions are equivalent. Let's get that in our notes. I can use properties to show that two expressions are equivalent. All right, so the first thing I see on the top of page 128 is a couple of highlighted words. So let's read that section. It says expressions with the same value, like 12 plus 7 and 7 plus 12, are equivalent expressions. You can use the commutative and associative properties to write equivalent expressions. So the first thing I want to talk about is this word equivalent, which really just means equal to or the same. So when we're looking at things that are equivalent, we're looking at things that mean the same thing. They have the same meaning. So the first two properties on the key ideas section there are called the commutative properties and associative properties. So we'll start with commutative. And the commutative properties you can use this for addition, where you're looking for the sum, or you can do multiplication, where you're looking for the product. So commutative works with the sum or the product. Basically, what the commutative property is saying is that if you have an expression and then you rearrange the order of the numbers, the answer is basically just going to be the same thing. So this one's all about rearranging the order. And then what you will have is the same answer. So here's a little example of the commutative property. If I had an expression that said 5 plus 8, it would mean the same thing as if I rearranged that order and I did 8 plus 5. So when I rearrange the order, I'm going to get the same answer. 5 plus 8 and 8 plus 5 are the same thing. And this would work for multiplication too. So if I did 5 times 8, that would be the same thing as saying 8 times 5. So rearranging the order is all about your commutative property. Your next property is the associative property. And very similar to the commutative, this will work with when you're adding or finding the sum of something, and when you're multiplying or finding the product of something. So what does the associative property say? Well, this one is all about the grouping of your numbers. So really, when I think of associative, I think of the parentheses. So I'm going to put little parenthesis marks here. And what it says is that you can regroup the problem and the answer is going to be the same. So this one's about regrouping. So regroup and you get same answer. So let's do a little example here with addition. So if I had parentheses around 7 plus 4, and then I have a plus 2. So my parentheses are saying, okay, I have to add 7 plus 4 first, and then I can add the 2. Basically, if I regrouped this, instead of putting the parentheses around the 7 and the 4, I put around the 4 and the 2, it would look like this. That would give me the same exact answer. So 7 plus 4 is 11, plus 2 more is 13. Then over here, if I did 4 plus 2, that'd be 6, plus 7, that's 13. So it doesn't matter where you group the parentheses when you're doing this sum. It's the same thing for the product. So if I grouped the 7 times 4 times 2 when I'm multiplying versus 7 times parentheses 4 times 2. So if I started my parentheses here, 4 times 7 would be 28. Then I multiply by 2. Or over here, 4 times 2 would be 8. Then I multiply by 7. It's going to give me the same answer either way. So that's called the associative property when we're taking parentheses and regrouping things to get the same answer. Those are our first two properties, commutative and associative. So let's take a look at our first example. It says using properties to write equivalent expressions. So we're going to use these properties now. So we'll switch colors. So example 1. This one has 3 different items next to it. So example 1a says simplify the expression. So I'm going to write the word simplify. That's the action we're going to take with this expression. So the expression says 7 plus parentheses 12 plus x. Now, this word simplify basically just means we're going to take this expression and make it shorter. So instead of 1, 2, 3 terms, we're going to see if we can get it down to 2 terms or even 1 term. And there's a letter involved that we have to remember. So something that I would think about here is the way that our parentheses are grouping. Right now, the parentheses are around 12 plus x. But up in our associative property, we know that if we took our parentheses and moved them around the 7 and the 12, we would get the same answer. So we're going to regroup this and make the parentheses go around 7 plus 12. And then I have our plus x on the end. And I'm going to put associative next to that, because we just use the associative property to regroup. So now we can go 12 plus 7, and 12 plus 7 would give us 19. So I have 19 here plus an x. So I just took 7 plus 12 plus x and I simplified it down to 2 terms using the associative property. I can't add 19 and x together because an x is an unknown number. So that's the shortest version that we can get here. Moving on to question B. Question B says simplify this expression, 6 plus 1 plus x in parentheses. So again, we're going to simplify 6 plus 1 plus x, and that's all in parentheses, and then plus 8.4. So let's take a look here. We have the parentheses around 6 plus 1 plus x. What I think I'd like to do first here is rearrange the order of these two things. So let's put the x first and the 6.1 second. That way our numbers are sitting closer together. So we're going to take and rewrite this if we just rearrange the order of those first 2 terms. So when we rearrange the order, remember that's called commutative. Now that we've rearranged the order, I'm going to now regroup. So I'm going to take these parentheses and move them around the numbers. So I'm going to leave my x on its own. And then I'm going to put parentheses around 6.1 plus 8.4. And when I take the parentheses and move those, that's called associative. Now we can add up 6 plus 1 and 8.4. So this x stays the same. And we have 4 plus 1 would give us 5. We have our decimal. 8 plus 6, 14. So I have simplified the expression by doing the commutative and the associative properties. And my last example for this one would be to simplify 5. So we'll write simplify again. We have 5 parentheses 11y. What I see happening here is a lot of multiplication. So remember, if there's no sign in between the 5 and the parentheses, it really means times. And if there's no sign in between a number and a letter, it also means times. So we're multiplying here. So what I would like to do is take these parentheses, and instead of putting around 11 times y, let's shift them and put them around 5 times 11 instead. So let's shift by going 5 times 11, and then let's put the times y on its own. So remember, when we take and shift the parentheses, that's the associative property. 5 times 11 is 55, and then we multiply by our y. We can't actually find the final answer here because we have a letter involved, and that is a variable that we don't know. So 55 times y, or 55y, would be the shortest way that we can rewrite that. Go ahead and pause the video if you'd like and try the 3 on your own at the bottom of page 128. Okay, so for number 1, you're going to be using the commutative property and the associative property in order to do this one, and your final simplified answer should be 19 plus a. And then number 2, turn the page here. It looks like you're going to be using the associative property for this one, and your final simplified version would be c plus 1 and 1/6. And then on your own number 3, we would be using the associative property as well, and our simplified version would be 20n, or 20 times n. Okay, I'm actually going to go back to using blue because we have a couple new properties to take a look at. So we will shift back to our blue. We're now looking at the top of page 129. And on the top, we have some new properties to take a look at. The first one is the addition property of 0. So we'll add that to our notes. And the property name kind of tells you what we're going to be doing in this property. The first word says addition, so this one we know is all about adding. So down here we're going to just put a plus sign, or the sum. And then also this word here, 0, there's going to be a 0 involved somewhere within this property. So basically what this one states is that a number plus 0 just equals the original number. So instead of writing that out in words, we're just going to put a number like 5 plus 0 equals the original number. So anything plus 0 is back to the original number. That's what the addition property of 0 states. So that's a pretty easy property to remember. And the next one is called the multiplication property of 0 and the multiplication property of 1. So let's get those two down. So the multiplication property of 0, we see the word multiplication, so we're going to be multiplying, and 0, meaning we're going to be multiplying by 0. So what that states is that if you have any number, doesn't matter what kind, and you multiply by 0, your answer is going to be 0. For example, if you have 5 and you multiply by 0, it is going to equal 0 every single time, no matter what. That's a pretty easy one to remember as well. And the last one we have today is called the multiplication property of 1. And again, the name kind of gives it away. So we have multiplication, so we're going to be multiplying. Property of 1, so we're going to be multiplying by 1 this time. So you can take any number and multiply by 1, and your answer is always going to go back to that original number, no matter what. So that's what the multiplication property of 1 states. So those last 3 properties are pretty easy to remember. We just have to be able to name them. So we're going to do some examples where we will practice naming those properties. So example 2 on page 129 says using properties to write equivalent expressions. Again, we're being asked to simplify some expressions. So we'll write the word simplify. And the first expression for question A says to simplify 9 times 0 times p. So couple of different things we can look at here. We have a p, which is a variable. We also have 9 times 0, which we know anything times 0 would give us 0. So if we do this piece first, 9 times 0 equals 0. 0 times p is what we'd have left over. What we just did there was the multiplication property of 0. And so what you see I've done here is abbreviated multiplication and property, so MP of 0. Now I have 0 and p. Well, anything times 0 is 0, so I know that this is going to equal 0 no matter what this p equals. So again, I'm using the multiplication property of 0, and I can simplify this expression all the way down to a final answer here. I know that whatever p is, this expression is going to equal 0. And now my question B. Again, it says simplify. Our expression says 4.5 times r times 1. So if we take a look at this, I'm seeing that we have an r times 1. So if I take r and I multiply it by 1, I know I'm going to end up back at my r. So I can take this piece and go, okay, well, r times 1 is going to end up being whatever r is. So I have 4.5 times r left over. So if we look back at our properties to name that, that was the multiplication property of 1, because we did multiplication by 1. So now if we take 4.5 and multiply it by r, we don't know what r equals, and so we really can't do anything else besides just take the 4.5 and put it right next to the r, because you don't have to have the multiplication symbol. So that really isn't another property. That's just taking what we have and smushing it together a little bit, because we don't need the multiplication symbol in between. So that is using the multiplication property of 1. Back on page 129, we now can move on to example number 3. Change colors. Example 3 is our real-life application. It says, you and 6 friends play on a basketball team. A sponsor paid $100 for the league fee, X dollars for each person's t-shirt or the player's t-shirt, and $68.25 for trophies. They want us to write an expression for the total amount that the sponsor paid. So we're going to write that expression and possibly simplify it a little bit to get it down to the most simplified version. So let's jot down some information they give us here first. Let's go ahead and scroll down. We have example 3. And this is our last example for the lesson today. So it says you and 6 friends. And why the heck would we put that down? Well, a lot of kids would look at that and say, oh, there's 6 total people. Well, if it's you and 6 friends, remember that that's going to be 7 people total, and that's going to come in handy later. The next thing they tell us is that the league fee is $100. And then the t-shirts, we're going to use a variable. We have an X for t-shirts, how much X t-shirts would be costing. And then trophies, they tell us that we spent $68.25. That's the stuff they give us in the problem. So it's saying that this sponsor paid this money, so they want us to write an expression for the total amount the sponsor paid. So if the sponsor paid $100, we're going to start with that. So we can go $100 plus, then the sponsor paid a certain amount of money, X money, for 7 t-shirts. So let's pause on that one for now and go to the trophies. So the sponsor paid $68.25 for trophies. And let's go back to our 7 and X. If there are 7 total people on the team and it's X dollars for each t-shirt, what we can do is take that 7 and multiply it by our X in order to find how much money that would be. So 7 times X, or 7X, would give us the total amount of dollars for the t-shirts. So if you take a look at this expression, we can actually simplify it a little bit These two things can actually be added together, 168.25, giving us 168.25 there. And we really can't include the 7x's inside this 168.25 because 7 has an x on it and we don't know what that x equals. So at this point, we are down to our most simplified version. So this would be our expression we would write for this situation. At this point, at the bottom of 129, you can pause and try out the on your owns 4 through 7. Okay, number 4. If you simplified that all the way down, that would end up equaling 0. Number 5, if you simplify that one all the way down, you would get 24m, or 24 times m. Number 6, if you simplified that one all the way down, it would be t plus 15. And lastly, number 7, the expression for that situation would be 7x plus 154.75, or 75 cents. And that concludes our Chapter 3, Lesson number 3.